Hello, everyone. My name is Dr. Christopher Moore, and I'm a research associate at West Virginia University, leading the day-to-day operations of our grant-funded pollution prevention team. Our team provides no-cost pollution prevention assessments and other related technical support to businesses within West Virginia. In the coming months, we'll be hosting webinars to discuss pollution prevention best practices for each of the EPA national emphasis area sectors. Today, I'll be presenting the first of the series, Pollution Prevention Best Practices for the Food and Beverage Manufacturing and Processing Industries. In this webinar, I'll first provide a brief introduction into pollution prevention as defined by the Environmental Protection Agency and what activities are and aren't considered pollution prevention. Next, I'll discuss EPA's national emphasis areas, which are prioritized industry sectors under EPA's pollution prevention initiative. The main focus of this webinar, however, will be the first national emphasis area, and that's food and beverage manufacturing and processing. So I'll provide some background into that industry. Then I'll cover several pollution prevention best practices that can be implemented by facilities within this sector to minimize their environmental impact and cut pollution at the source. Then after a brief summary, I'll do my best to answer any questions you have. If you have questions along the way, feel free to send them in the chat and I will address them after the presentation. So before diving into the topic of pollution prevention, we first need to understand what pollution is. So according to the Oxford Dictionary, pollution is the introduction into the environment of a substance or thing that has harmful or poisonous effects. Pollution has far-reaching consequences, not only affecting human health, but also disrupting ecosystems and threatening biodiversity. Given these impacts, it's clear that immediate action is needed to reduce pollution and its adverse effects. Now, pollution prevention, as defined by the U.S. Environmental Protection Agency, refers to any practice that reduces, eliminates, or prevents pollution at its source before it's created. This approach differs from pollution control, which typically deals with managing pollution after it's been generated. Instead, P2 generally focuses on proactive steps to prevent waste and pollution from occurring in the first place. So this hierarchy of pollution management on the screen shows a step-by-step approach to managing pollution, starting with the most desirable actions at the top and moving down to the least preferred options at the bottom. So when possible, the creation of pollution should be prevented in the first place. If the creation of a pollutant can't be completely prevented, the next objective should be to reduce the amount that is created. And when the amount of a pollutant can't be feasibly reduced, the other options, the best options are to reuse or recycle the pollutant, and that should be explored. Then the next step, recover, refers to the process of extracting any useful material or energy from the waste. And finally, the least preferred method option is disposal, where the waste will go into a landfill or otherwise just be released out into the environment. So EPA's pollution prevention initiative emphasizes this hierarchy, encouraging a primary goal of preventing and reducing pollution at its source. So as part of the EPA's pollution prevention initiative, in 2015, several priority sectors known as national emphasis areas were identified. These sectors were identified as priorities to focus resources and efforts for maximum environmental and economic impact. These sectors offer substantial pollution prevention opportunities and create a focused approach that allows for better resource allocation and the ability to share successful strategies across similar industries. Originally, the 5 NEAs were number 1, food and beverage manufacturing and processing. Number 2, chemical manufacturing, processing, and formulation. Number 3, automotive manufacturing and maintenance. Number 4, aerospace product and parts manufacturing and maintenance. And number 5, metal manufacturing and fabrication. Now, several years ago, a 6th national emphasis area was established, but instead of focusing on a specific industry sector, the EPA realized the need for assistance with pollution prevention on tribal and native lands within the country. So the focus of the discussion today will be the first national emphasis area, the food and beverage manufacturing and processing sector. And in the coming months, we'll be hosting webinars that cover the other 4 industry focus NEAs. So keep an eye out for more details about those. So the food and beverage manufacturing and processing sector includes industries classified under the NAICS industry classification codes, beginning with 311 and 3121. In 2020, there were over 36,000 establishments within this sector, with over 1,700 of them reporting to the toxics release inventory, which means that they have some sort of pollutant release from their facility. So the chart on the slide shows the volume of waste managed by different approaches from 2011 to 2020. Now there was a significant increase in the proportion of waste managed through recycling and treatment during this period. And this positive trend indicates growing awareness and adoption of sustainable practices within the industry. So this increasing reliance on recycling and treatment is a promising development. And these methods not only reduce waste disposal, but also contribute to resource conservation and energy recovery. However, despite the progress, there's still a substantial volume of waste being disposed of or released, and the amount of waste being disposed has not actually decreased really over that time period. So this represents a significant opportunity for further improvement and implementation of pollution prevention practices within this sector so that we can start chipping away at the actual amount that's disposed or released instead of just keeping up with the growing amount of waste that's produced. So there are numerous industries within the food and beverage manufacturing and processing sector, encompassing a wide range of industries from animal food manufacturing to distilleries. The industries within this sector can be grouped into 8 different categories. That would be animal food manufacturing, grain and oilseed milling, fruit and vegetable preserving and specialty food manufacturing, dairy product manufacturing, animal slaughtering and processing, seafood product preparation and packaging, bakeries and tortilla manufacturing, and different other food manufacturing, including breweries, wineries, and distilleries. So now that we've explored the diverse landscape of the food and beverage manufacturing and processing sector, let's begin discussing some of the pollution prevention best practices for this sector. The best practices that we will be discussing can be broadly classified into 4 categories. First, we will discuss some practices related to efficient water management, including wastewater reduction. Then we'll discuss best practices that focus on minimizing pollution from cleaning and sanitation processes. Next, We'll explore some best practices related to energy efficiency that can reduce carbon footprint, reduce environmental impact, while also saving money. And finally, we'll look at some pollution prevention practices related to efficient waste management. So first, we'll discuss water management. So water is one of the most used resources in the food and beverage manufacturing sector. Water is sort of the lifeblood of these industries, serving as a critical raw material in numerous processes. You'll be hard pressed to find a facility in this sector that does not use water for at least one crucial industrial process. The extensive requirement of water usage across countless processes can create a strain on the environment and local water resources, especially in areas that often have drought conditions. So these large water requirements, they often lead to a significant amount of wastewater generated by these facilities as well. So reducing the amount of water used invariably is going to result in a reduction of wastewater generated. So it's a win-win. The exhaustive use of water and generation of wastewater poses a significant environmental and economic challenge. Additionally, as potable water sources are depleting, optimizing water usage and managing water reuse has become imperative. So in this section, we'll be discussing several best practices related to water management. So first, the wastewater generated by food and beverage manufacturing industries is often full of organic matter and other pollutants. Directly discharging such wastewater is not only environmentally harmful, but can also be illegal, leading to fines and other penalties from regulatory agencies. So to comply with regulations, facilities must monitor and control parameters like pH, volume, and temperature of wastewater discharges. And this is where equalization tanks come into play. So equalization tanks can be a great asset in water pollution control in the sector. They act as holding tanks, collecting and storing incoming wastewater to stabilize its flow rate, its pH, and its temperature. Equalization tanks allow for precise control of chemical usage to adjust the pH to optimal levels. The usage of an equalization tank ensures that the chemicals to control the pH can be accurately applied, ensuring proper pH control while making most efficient use of chemicals, while improving proper handling and accountability of the chemicals that are used to modify the wastewater to meet standards. Additionally, equalization tanks allow better control of oxygenation and temperature. Aeration and proper temperature improve the speed and efficiency of the treatment process, promoting biological degradation of organic matter. Aeration or external heating and cooling systems can be used to regulate the temperature of the wastewater. Also, by storing wastewater, equalization tanks help balance fluctuating incoming flows, especially during peak production periods. Equalization tanks act as buffers, smoothing out variations in wastewater and ensuring efficient and effective treatment. They also control the release of wastewater, preventing overloading of downstream treatment processes and optimizing their performance. So what are some of the benefits that can be expected from using equalization tanks? First, they help ensure compliance with strict discharge regulations. So by stabilizing the flow, controlling the pH, and the temperature of the wastewater, equalization tanks enable efficient treatment and minimize the risk of regulatory violations. Second, equalization tanks help in optimizing the chemical usage in wastewater treatment. By allowing for precise dosing, these tanks reduce the amount of chemicals needed for treatment and help minimize the environmental impact associated with the use and disposal of these chemicals. Next, equalization tanks contribute to a cleaner environment, helping both aquatic and human life. They improve the efficiency of wastewater treatment processes and help in reducing the release of pollutants into the environment. And finally, the cost savings associated with the use of equalization tanks can be substantial. By optimizing treatment processes and reducing chemical usage, these tanks can significantly lower operational costs for wastewater treatment. So in a case study of a baked goods facility, the implementation of an equalization tank in the facility resulted in savings of 16,600 pounds of caustic soda and 9,400 pounds of sulfuric acid annually, resulting in savings of $8,400 per year in raw material costs alone. So next, especially in breweries, maintaining proper sanitation requires thorough cleaning and washing of brewing and fermentation tanks. However, this process generates a significant amount of wastewater. One effective strategy to reduce this wastewater is by reusing the final rinse water for an initial rinse of another tank. Despite this final rinse water being clean, it is often just discharged. So reusing the final rinse water in the initial rinse of the next cleaning cycle is a highly effective wastewater reduction strategy known as cascade rinsing. So when cleaning brewing and fermentation tanks, multiple wash and rinse cycles are used. The first cycle employs clean water to wash away many of the deposits from the tanks. And this water, which is now highly contaminated, is either purified or discharged. So more rinse cycles after the first are performed, and for each cycle, the amount of contamination in the water is going to reduce until the final rinse. The final rinse water then is almost completely free from minerals and other contaminants. So it can be collected and reused as the initial rinse water when cleaning the next tank, the next piece of equipment, or the next cleaning cycle. So this approach can reduce water consumption and reduces the volume of wastewater generated. And while this best practice is most relevant to breweries, it can also be implemented in other industries within the sector where repeated rinse cycles on equipment are used. So by adopting cascade rinsing, breweries can significantly reduce their water usage and contribute to a more sustainable future. By reusing rinse water, breweries reduce their overall water consumption, which is crucial in such a water-intensive industry. Reduced water use also provides savings in water utility costs, and these reduced utility costs essentially cut your operating costs. Additionally, these practices support sustainable and green production, showcasing the brewery's commitment to eco-friendly practices, which can boost its brand reputation. And finally, reusing the water ultimately means generating less wastewater, which reduces treatment costs and eases the load on local facilities. So in one case, a distilling company planning to implement cascade rinsing determined that they would realize significant savings with minimal expense. They would potentially save an estimated 160,000 gallons of water each year, which would correspond to an annual savings of around $10,000. Now, like the cascade rinsing process, the fruit and vegetable processing industries can benefit from a somewhat similar technique. So fruit and vegetable processing industries generate a huge amount of wastewater during the scrubbing process. Reusing that water can have substantial environmental and economic benefits. So In that sector, incoming produce must first undergo rigorous cleaning and scrubbing to remove dirt, debris, and microorganisms and other contaminants. This cleaning process generates a significant amount of wastewater, which is often released instead of reused. So instead of discharging the scrubber water, the water can be reused in the scrubbing process to clean subsequent batches of produce. However, before reusing the water, it must be filtered to remove dirt, debris, and other contaminants and disinfected to make it suitable for the scrubber process. Reusing the scrubber water can drastically reduce overall water consumption and reduce volume of wastewater discharge. However, the additional expense and considerations of the filtration and disinfection process must be considered when you're making a cost-benefit analysis of this. So reusing scrubber water in fruit and vegetable processing can offer a number of advantages. First, it provides a significant reduction in water consumption. Reducing water usage leads to lower utility costs, making the process more cost-effective. Furthermore, water reuse aligns with sustainable and green production practices. It minimizes the environmental impact by reducing water pollution and conserving this resource. Additionally, by recycling water in the scrubbing process after treatment, the volume of wastewater generated is drastically reduced, which in turn eases the burden on wastewater treatment facilities. Reusing scrubber water is a sustainable and cost-effective practice that promotes environmental responsibility and economic efficiency in the food and beverage sector. In one case, a potato processing facility was able to implement a filtration system that allowed them to reuse the scrubber water, resulting in an estimated reduction in water usage of over 8 million gallons per year per scrubber. So this shows the great potential of reusing the scrubber water with savings that easily surpass the cost of implementing the water filtration system. Next, brine, which is a mixture of salt and water, is used for fermentation and food preservation in the food and beverage sector. Generally, industries will use the brine solution and discard it. When feasible, reusing the brine can save money by reducing the need for water and salt. So in industries like pickling, cheese production, olive processing, brine is used extensively. And the brine acts as a preservative and provides an optimal environment for bacteria to work and thrive during fermentation. And as mentioned, facilities often discard this brine after using it once, causing tremendous water and salt use in these processes. So reusing the brine is often possible, but it's going to require proper monitoring and consideration of the quality of the used brine. So reusing brine, when appropriate, can result in large savings of salt and water. So to effectively reuse brine, though, without risking the integrity of the process, a robust biological activity monitoring system should be developed to ensure safety to human health. But by collecting used brine, monitoring its quality and proper preparation, the brine can be reused in subsequent production cycles. So the practice of reusing brine comes with several advantages for these facilities. Again, there's going to be water savings as well as savings in salt. That's going to reduce the utility costs and the operating costs, which is going to improve the profitability of the facility. And along with the reduction in water usage, again, there's going to be a reduction in wastewater volume as well. And again, brine use is going to reduce the overall environmental impact of the food production process. So in one case study of a pickling plant where they perform pickling of foods, it was estimated that reusing brine would reduce annual salt use by 213,000 pounds, save 214,500 gallons of water, and that's all going to produce an annual savings of over $20,000. So the final best practice we'll talk about relating to water management is to install low flow faucets with aerators and to utilize continuous monitoring of water use. And these are some simple yet impactful ways to reduce water consumption in industries. So low flow aerators are small devices that attach to the faucet spout, and they significantly reduce the water flow by introducing air bubbles into the water stream. And that's going to save water without compromising water pressure. Furthermore, flow meters can be implemented for constant monitoring of water usage in different processes. So constant process-specific monitoring of water usage by flow meters can allow better control of water usage, reducing the amount of water being unnecessarily used. A certain volume of water is needed for a process to function efficiently, and using any more water than that in the process is going to be a waste. So monitoring water usage with flow meters can also help in identifying and addressing possible leaks. So when you're expecting a certain amount of flow and it's different than what you expect, that could indicate some sort of issue, either with a leak or something else in your process. So implementing these devices throughout your facility can provide significant water savings, again, reducing wastewater and reducing related costs. Also, the low cost of these devices means that they pay for themselves quickly, so you can start seeing real savings. So now that we've completed our discussion on best practices related to water management, let's move on to another important area of pollution prevention best practice for the food and beverage manufacturing sector, and that's going to be sanitation and cleaning. So, in this sector, proper sanitation and cleaning are essential as they directly impact human health and the safety and quality of the product. However, some modifications to these processes can be made to enhance efficiency and reduce the environmental impact without compromising process effectiveness. So let's discuss a couple of these methods. First, in breweries especially, thorough cleaning and sanitation of equipment is essential to maintain product quality and food safety. Traditionally, bleach has been used as a common sanitizing agent, but its use can have negative environmental impacts. Switching to a sodium dichloroisocyanurate-based sanitization process offers a more sustainable and effective alternative. So again, I mentioned sanitizers commonly used in breweries include bleach base, or are often bleach based, or they contain chemicals such as phosphoric acid or sulfonated oleic acid. And exposure to these chemicals can have impacts on human health. Acutely, exposure to these chemicals is associated with causing eye and skin irritation. Chronic, prolonged exposure to these chemicals can lead to nervous system damage and reproductive health issues such as birth defects. Replacement of these sanitizers that can impact health with safer alternatives eliminates these risks. One such alternative, as I mentioned, is sodium dichloroisocyanurate, or NADCC. So NADCC is the active ingredient in products like BrewTab and PureTabs, and it has several benefits over bleach and acid-based products. So first, NADCC creates an available chlorine solution that is very efficient in the disinfection and sanitization of a range of microorganisms. So from a pH perspective, compared to bleach, which is highly basic with a pH of around 12, and phosphoric acid, which is highly acidic with a pH of around 1, NADCC instead is almost neutral with a pH of approximately 6.5 when dissolved in water. This safer pH level means there is a reduced effect on the skin and it's less likely to damage surfaces that it's used on. Additionally, NADCC discharges about 50% of the total chlorine in water as free available chlorine, which is an effective disinfection compound. Since the free available chlorine is used up in the disinfection process, the NADCC continues to release chlorine, thus sustaining the 50-50 ratio in solution for longer disinfection power than with bleach. Also, besides being efficient and safe compared to traditional methods, NADCC tablets are also more sustainable. Their compact form means they occupy little storage space, and since they're tablets, they're safer and easier to handle, transport, and use compared to bleach and other liquid disinfectants. Therefore, switching to these kinds of cleaning agents can improve the efficiency of the sanitation process, reduce the risk of health effects for the employees, and reduce the pollution footprint of the facility, all from a very simple product swap. The other best practice that we'll discuss relating to sanitizing and cleaning processes is using dry ice cleaning methods. These have several key benefits over traditional cleaning methods like hand washing and pressure washing. So traditional cleaning methods in the food and beverage industry, such as hand washing and pressure washing, rely heavily on harsh chemical agents and are very water intensive. As discussed earlier, chemical cleaning agents can be toxic, they can contaminate water bodies, and lead to skin irritation, respiratory problems, and other health issues for workers on exposure. Furthermore, traditional cleaning methods are often labor-intensive and time-consuming, requiring significant manpower and resources. So, to address the limitations of these traditional cleaning methods, dry ice cleaning offers a sustainable and effective alternative. This technique utilizes solid carbon dioxide pellets to blast away dirt, grime, and other contaminants. The dry ice, after being blasted onto the surface, quickly sublimates into carbon dioxide gas without leaving any moisture or residue behind, which makes it a very environmentally friendly process. Dry ice is also non-toxic and non-flammable. Dry ice cleaning has several other key benefits as well. First, dry ice cleaning uses soft, non-abrasive dry ice media, which makes it a very versatile cleaning process, able to be used on a wide range of surfaces, even sensitive surfaces, including electronics, metals, plastics, ceramics, painted surfaces, and food processing equipment. Next, unlike traditional cleaning methods, dry ice cleaning does not require water, which can conserve a significant amount of water and eliminate the need for harsh chemicals over the traditional cleaning methods. And aside from reducing water costs, the need for wastewater management is also reduced. Additionally, not having to rely on harsh chemicals for cleaning means safer tasks for the employees. And finally, dry ice cleaning is a highly efficient method and can drastically reduce the time and effort it takes to clean equipment using traditional methods. The figure to the right demonstrates the cleaning ability of dry ice cleaning. So a Texas bakery implemented a dry ice cleaning method, and we're able to reduce 24 to 30 man hours per week, which could represent a savings of $15,000 in wages alone. So next, we'll shift gears and briefly discuss a couple of methods for improving energy efficiency in the food and beverage manufacturing sector. So most energy use, either directly or indirectly, involves the use of fossil fuels such as coal, petroleum products, or natural gas. Not only are these fuels used directly to generate heat for processes or comfort in the facility, but most electricity itself is initially generated by burning fossil fuels as well. Therefore, embracing energy efficiency and utilizing green energy sources can reduce environmental impact and improve profitability. So first, let's talk a little bit about boilers. Boilers are essential components in many food and beverage processing facilities, providing the necessary heat and steam for various operations such as sterilization, pasteurization, and heating. Maintaining the air-fuel ratio to the proper level ensures complete and efficient combustion of the fuel, meaning that as much of the fuel as possible is turned into usable heat or energy. So maintaining the correct air-fuel ratio is crucial for optimal boiler performance. An improper air-fuel ratio can have several negative consequences. So if the amount of air is too low and the mixture is richer than required, the fuel will not be completely combusted. This is gonna lead to overall boiler inefficiency by wasting fuel. The flame may become unstable, and it could result in high levels of carbon monoxide and hydrocarbon emissions from that incomplete combustion of the fuel. And on the other hand, when the amount of air is too high and the mixture is leaner than required, it will result in heat loss and higher combustion temperature. Furthermore, it's going to increase emissions of nitrogen oxides and sodium oxides, especially if there is high sulfur content in the fuel. Therefore, maintaining a proper air-fuel ratio is a must for optimal boiler performance. So the right balance of air and fuel fed into the boiler helps in maximizing heat transfer, minimizing fuel consumption, and reducing harmful emissions. The following are a few strategies that can be used to ensure proper air-fuel ratio. First, there are commercially available control systems that can be used to monitor the combustion efficiency and automate the adjustment of the air-fuel ratio to optimize efficiency and performance. Now, this strategy is going to be one of the more expensive strategies on the list. So it may not be a feasible option, especially for smaller businesses or businesses that are running on a tighter profit margin. For businesses like that, we can look at things, and even with the control system, we should be looking at keeping the burners and the fuel lines regularly cleaned and maintained. It's a simple process, and it's going to help maintain consistent performance of the boiler. So additionally, related to maintenance, we want to make sure that the air allowed into the combustion chamber is strictly and precisely controlled to optimize combustion efficiency. Reducing unwanted air infiltration into the combustion chamber is going to be important to maintain a precise air to fuel ratio. So the only air that we want getting into the system is the air that we allow into the system intentionally. Any excessive air is going to throw off our air fuel ratio and reduce the efficiency of our boiler. Next, proper startup and shutdown procedures can ensure that the air-fuel ratio is unaffected. And finally, in-depth training should be provided to boiler operators. Operators should be trained to properly operate the boiler, make informed adjustments to the air-fuel ratio based on real-time data, clean and maintain the burners and fuel lines, and monitor flue gas composition to ensure that air-fuel ratio is correct and that the boiler system is running at peak efficiency. Monitoring flue gas composition with a combustion analyzer can give valuable insight into the combustion efficiency and alert the operator to any issues with the boiler system that will need attention. So most people are aware of the benefits of using solar technology to generate electricity, but there are other ways that solar technology can be used in the food and beverage manufacturing sector. So solar generated energy can be utilized in various ways within the food and beverage industry. As mentioned, one such application is the use of photovoltaic panels to generate electricity. These panels can be installed on rooftops or other unused spaces, providing a sustainable source of power for operations. One technique that is becoming popular is installing photovoltaic panels in parking lots over top of the parking spots. This provides shade to the vehicles parked beneath, generates electricity with the solar panels without requiring the extra space that some large solar installations would require. So another promising technology aside from photovoltaics and generating electricity is solar thermal energy. So instead of using the heat collected by these from the sun to generate electricity, we can use that heat directly for various industrial processes. So we can use that to generate heat for cooking, sterilization, drying processes, etc. So for processes, in one case for processes that require hot water, solar thermal energy can be used to heat the water instead of using electricity, natural gas, or other fuels that are going to directly or indirectly require the use of fossil fuels. Solar power can even be used for refrigeration. So don't think that just because you're collecting heat that you can only use it for heating. It can also be used for refrigeration. So anytime that reliance on conventional energy sources that involve the combustion of fossil fuels can be replaced with methods utilizing clean, renewable energy sources, there will be a significant reduction in greenhouse gas emissions. So by adopting solar energy solutions, facilities within the food and beverage manufacturing industry can significantly reduce their carbon footprint, lower their energy costs and dependencies, and improve their environmental image. Overall, it will help in pollution reduction and will be a leap toward sustainability. Furthermore, facilities can take advantage of various government incentives and net metering programs to offset costs and maximize the benefits of solar energy. The Inflation Reduction Act of 2022 introduced several significant tax credits for clean energy investments, including the investment tax credit for energy property and the clean electricity production credit. By leveraging these incentives, businesses can significantly reduce the upfront costs of solar energy projects and accelerate their transition to clean energy. And finally, we'll take a look at pollution prevention best practices related to management of waste. So food waste is a significant problem in the United States, with over 100 million tons of food waste per year. According to the EPA in 2019, a staggering 66 million tons of food waste was generated by the food retail, food service, and residential sectors, and most of this waste was sent to landfills. Additionally, the food and beverage manufacturing and processing sectors contributed another 40 million tons of food waste. These statistics highlight the significant amount of organic waste generated and discarded by the food and beverage industry. Improper management of this organic waste can not only lead to serious health and environmental hazards, but disposing of this waste can be costly for the facilities. So there are a couple of options for recycling this waste into useful product. One effective solution to address the issue of food waste is composting. And composting involves the controlled decomposition of organic matter, such as food scraps and yard waste, into nutrient-rich compost. Compost has several benefits when applied to crops as fertilizer, including increased soil fertility, increased crop yield, and less reliance on chemical fertilizers. So instead of paying for the disposal of this food waste, businesses can make arrangements with local farmers or other agricultural facilities that can benefit both of these entities. So the manufacturer could give away or cheaply sell the food scrap to local farmers, eliminating their disposal costs. Or the manufacturer could instead, if they have the space for it, compost the food waste and sell the compost themselves as an added source of income. Regardless of which option is chosen, the farmer will have access to low cost, high quality fertilizer, and the food and beverage manufacturer can reduce the costs associated with disposal of the waste. Additionally, composting has significant environmental benefits, including reduced greenhouse gas emissions and conservation of valuable landfill space. Additionally, compost can be used to enrich soil, improve plant growth, and reduce the need for chemical fertilizers. Facilities can achieve this by coordinating with local farmers by sourcing their organic waste to make compost manure. Another alternative, an alternative to composting is anaerobic digestion. And anaerobic digestion involves using microorganisms to break down organic matter in the absence of oxygen. So anaerobic digestion is a four-stage process: hydrolysis, acidogenesis, acetogenesis, and methanogenesis. And essentially, this four-stage process breaks down the organic matter into simpler and simpler compounds, ultimately converting the organic material into water and biogas. Now, biogas is going to be comprised mainly of methane and carbon dioxide with trace amounts of some other gases. This biogas can be purified and used as a fuel like natural gas to either generate electricity or provide heat for comfort or for process heating needs without using fossil fuels. So in other words, in a food and beverage manufacturing facility, instead of food scrap being a waste with disposal costs, it can be utilized as a low-cost, environmentally friendly source of energy. And in addition to biogas, anaerobic digestion produces what's called digestate, which is a nutrient-rich fertilizer that can be applied to agricultural land to improve soil fertility and again, reduce the need for chemical fertilizers. So this is another byproduct that instead of being an expense, you can turn it into a source of income. So both composting and anaerobic digestion offer significant environmental and economic benefits. Composting reduces the amount of organic waste sent to landfills, minimizing greenhouse gas emissions. It also produces nutrient-rich compost, which can improve soil health and reduce the need for chemical fertilizers. Additionally, composting can generate additional revenue through the sale of high-quality compost. Anaerobic digestion, on the other hand, converts organic waste into biogas, which is a renewable energy source that can be used to generate electricity or heat. It also produces digestate, which is a valuable fertilizer that can enhance soil fertility. So by reducing the volume of organic waste and generating renewable energy, anaerobic digestion contributes to a more sustainable future. So in summary, today we discussed the concept and importance of pollution prevention and discussed several best practices targeted at the food and beverage manufacturing and processing industry. The best practices we discussed were focused on the four broad categories of waste management, water management, sanitation and cleaning, and energy efficiency. Each of these best practices are well supported and can be implemented to improve sustainability, minimize environmental impact, and reduce operating costs of the facility. So for more information on any of these best practices, including technical assistance, you can reach out to myself, Dr. Moore, or to Dr. Ashish Nimbarte. Also, please feel free to reach out to us with any other information or assistance related to pollution prevention as it applies to the NEAs or to other industries, and we'll do our absolute best to help you out. This is the references that were used within this presentation. Does anybody have any questions? All right, then with that, I'd like to thank you all for joining us for this presentation. And again, keep an eye out for our future webinars in this series that will cover the other four EPA national emphasis areas.